Hello, my name is Gavin Walker. I'm from the JBS Law Magnet. This is free response question number 1, 2012 AB2. The question gives us a graph and a statement that says, let R be the region in the first quadrant bounded by the x-axis in the graphs of y equals natural log of x and y equals 5 minus x as shown in the figure above. For A, it's asking us to find the area. So what you would do, you would plug in the graphs or the two graphs into the calculator. I already did that. And then afterwards you would find the intersection point. It intersects at x equals 3.693 and y equals 1.306556. We're going to use the y coordinate since it makes more sense for this graph. So we're going to plot our points, but before we can plug in our equations, we have to find the equations in respect to y. So y equals ln x, then set the e, so x equals e to the y. And then we do the same for the other one. Y equals 5 minus x minus 5. Subtract 5 from both sides. Y minus 5 equals negative x. And then multiply both sides by negative 1. And then negative y plus 5 equals x. So then now we're ready to plug in. You do right minus left. So I'm going to be plugging in the negative y plus 5 first, and then subtracting e to the y, and then dy, and then that answer, and then we plug it in. Math 9, 0 to 1.3065586. The reason there's so many decimal points is because you want it to be as accurate as you can get it. So vars, y vars function 2 minus y vars function y1. Just gotta make sure. Okay, great. Oh wait, my bad. You wouldn't want to plug in those. You'd want to plug in your these. So it would be negative y plus 5. You can really plug any variable into the equation, it'll work just as good. E to the x. Make sure you close your parentheses, and then dx. And then you press enter. Then you should get 2.986. Okay. So that's all we do for A. Now for B. B is asking us to find the volume. So what we're going to do, we're going to do the same thing, except it's going to be squared and multiplied by pi. So pi 0 to 1.306556. We know what, we're going to go ahead and set this as y1. Or no, we'll set this as x1 and x2. So just that way we can have it right here as a reference. So x1 minus x2, then both of these are going to be squared, dy. So then we're going to have to plug it back into our calculator. So you can insert square. After you do that, you'll be getting 18, and then you multiply that by pi. Then you'll be getting 58.28 as your answer. Okay. That's all for B. Now for C. C is asking you, C says region R is the base of the solid. For the solid, each cross section is perpendicular to the x-axis as a square. Write but do not evaluate an expression involving one or more integrals that give the volume of the solid. So for this, the equation of the square base is like the for the square volume is like the pi. It's like the regular volume equation except no pi. So 0, 1.306558 times x1 squared minus x2 squared dy. Then that would be equal. Let's see. Oh, we just set up the equation. So then that would be all you would need to do. No calculations or anything. So now on to D. Okay, so D says we gotta do the same thing, just set up an equation, but this time it's gonna be for an equilateral triangle. Now that's gonna be a little different. The number outside of the sigma is gonna be square root of 3 over 4, and then everything else is gonna be the same. 0.3065586 x1 squared minus x2 squared dy, and that's all we have to do for D. Now for E, what we're going to be doing for E is asking to find the volume of a solid formed by revolving the region R around the horizontal line y equals 2. So all we're going to do is going to be, you need to draw our little 2 line up here, and then I'm just going to be doing top minus bottom, kind of. So it's going to be big R minus little r. It's going to be pi 0, 1.3065586 times 2 minus x1. Remember, x1 is that this y minus negative y plus 5 up here. Then we're going to be subtracting that. 2 minus x2 squared dy. Then we plug that into the calculator. Okay. Okay. Just hit enter. Multiply by pi. And then you'll get 20.759 as the volume of E. Then we'll move on to F. F says, find the volume of the solid formed by revolving the region R around the vertical line x equals 5. It's going to be very similar to E, except it's going to be a little different. 3655886, and so we'll draw our line at right here at the 5, and then again we're going to do the big R minus little r. Since the big R goes to the e to the y line, that's the one we're going to do first. So 5 minus e to the y squared minus 5 minus negative y plus 5 squared dx. plus 5 to the, and then we plug that in, and multiply it by pi, and then you should get 35.51521 as your answer. So that's all for F. For G, G is similar to C and D, and that all we have to do is write an expression. So it's going to be with a rectangle. A rectangle with a height of 2. So really all that it's doing is setting it up for a square and then multiplying it by 2. So 2, 0, 1.306558 times x1 squared minus x2 squared. Just checking to make sure. Yep. Okay. dy. And then that's all for G. For H, what we're going to do is try to figure out how we would find K. We don't actually have to find K, but we're just going to figure out how to do it. So since it says K divides R into 2 equal regions, really all we have to do is write the integral expression for area and then divide it by 2. Or put it over 2. So 0 and then 3065586 x1 minus x2 dy all over 2 equals K. And now time for J. After J we got 2 more. Okay, so J, it says it's again similar to G. All we have to do is set up an integral expression. So G, it says the isosceles triangle where the leg is on the triangle. So with the leg, we're going to have where it's going to be similar to G, except it's going to be 1/2 since it's an isosceles triangle, and an isosceles triangle with the leg on the base, it's going to be half of a square. So it's going to be 1/2, 0, 1.306558 times x1 squared minus x2 squared dy. And then that's all for it is for J. Now for K, what we're doing is again setting it up and not solving for a semicircle though. So a semicircle is going to be semicircle is going to have it as pi over 2 times 0, 1.306558 and then x1 squared minus x2 squared dy. And then lastly is L. L, again, all we have to do is set up and not solve. It's for an isosceles triangle with the hypotenuse on the base. Now that's, again, similar to the leg on the base, except it's going to be 1/4 versus 1/2. It's going to be 1/4. 1/4. Oh, hold on a second. Back to K. It's not pi over 2. My bad. It's pi over 8. No. It is pi over 2. It's pi over 2. And 0, 1.306558 x1 squared minus x2 squared dy. And that's it. That's all it is for problem number 4. Thank you for watching.